begin our lecture on section 5.2, we need to finish up our lecture on section 5.5 that we started last Thursday. On this next problem, again, recall that we are going to be looking for a composite function, see if we can find one, and if we take a look at this, that is our composite function. So we're going to begin by saying let u equal the inside function, which would be x squared plus 2x. Then we're going to take the derivative of u with respect to x, and that would be our 2x plus 2. We see up here that we have a differential x. We also have an x plus 1. So one thing we could do is to rewrite this as e to the x squared plus 2x power, and then put x plus 1 dx together. Because now when I look at that, and I consider that 2x plus 2 is the same, but it has an additional factor of 2, I'm going to multiply, first of all, both sides by my differential x. If I factor out the 2, and then look at and consider that x plus 1 dx is the same as my x plus 1 dx, so I'm going to multiply both sides of this by 1/2. I'm ready now to make the first substitution. Okay, so substitution number 1. We're going to take the original problem, and instead of having it in terms of x, we're going to write it as e to the u times 1/2 du. This makes it a much easier problem to work. It's a very simple problem. Well, first of all, let's take care of the scalar. So we can say that's 1/2 the indefinite integral of e to the u du. Now we have a simple problem where we think, what is the function whose derivative is e to the u? Recall that all of this integrand is a derivative. And we are looking for what is the function that would yield that derivative. So we can say that the function that yields e to the u as a derivative is simply e to the u. And then remember, we have to add that constant of integration. This now is my function, but it's now in terms of u. I need to go back and make sure that I am true to the original problem, which means that it's in terms of x. So this is when I make my second substitution, and I look at what is u. Well, we let u be x squared plus 2x. So that makes it 1/2 e to the x squared plus 2x plus c, or simply f of x equals 1/2 e to the x squared plus 2x power plus c. Remember, how do we check this? Well, to check this, we would take the derivative of this function, and if we don't get back to the original, then we know we have an error in there. So let's see, this would be 1/2, and the derivative of e to a power is simply e to that power. And then we must take the derivative with respect to x of the inside function, and the derivative of c is 0, of course. So we have 1/2 e to the x squared plus 2x times 2x plus 2. I can again factor out a 2, and we would have e to the x squared plus 2x power times x plus 1. Is that the same derivative we started with? And the answer is yes. Okay, moving on to the next problem. Again, we're going to look for a composite function. On first glance, it may not appear to be evident what we have as a composite function, but take a look at this denominator. There we have a quantity, a function, raised to the second power, so there is our composite function. So the first thing we do is let u represent the inside function, so e to the x plus e to the opposite of x. Take the derivative with respect to x. E to the x is simply e to the x. Derivative of e to the negative x is e to the negative x. Then we must take the derivative with respect to x of the exponent. Remember, it's not simple e to the x, it's e to the opposite of x. So we have du equals e to the x, actually du dx at this point, e to the x plus e to the opposite of x times -1. If we multiply both sides by the differential x, we would have e to the x minus e to the opposite of x. All of that times dx. Now, if we go back and look at our original problem, and if we write that, we would have e to the x plus e to the opposite of x raised to the -2 power, and then I'm going to move the e to the x minus 2e to the opposite of x dx beside each other. Okay, taking a look at this, now before we've always had an additional factor showing up here, and instead we have it over here. So if I'm going to have this be where I can make a direct substitution in there, I'm going to have a factor of 2 in this place. And so I'm going to do one more rewrite, e to the x plus e to the opposite of x to the -2, and I'm going to factor out a 2 from here, and that gives me then e to the x minus e to the opposite of x dx. And now if I take a look at that, I'll see that I have exactly the same thing that I need. So I'm ready to make my first substitution. And in the first substitution, we're going to make this the indefinite integral of u to the -2 times 2 du. 2 to the -2, because u is this quantity. The 2 we haven't done anything with. It was factored out, and this inside the brackets is what I'm replacing du with. So I could say that it's 2 times the indefinite integral of u to the -2 du. Now if I take that indefinite integral, I'm going to have 2 times, remember our rule is very simple, add 1 to the exponent, divide by the new exponent, plus c, or -2 times u to the -1, divide by -1, plus c. This is our function, the original one. So if I'm looking at that, I could say that it's -2, u to the -1 plus c. If I go back and do now my second substitution, I would have f of x equals -2 divided by u. Now let's see, u was e to the x plus e to the opposite of x. So this would be e to the x plus e to the opposite of x plus c. Again, we can check this by taking the derivative of this, and we should get right back then to this quantity because this is our derivative. Now, as a reminder, let's just do t. Okay, this problem, each one gets a little bit more complicated, a few more things to think about, but basically we're going to do the very same thing. We're going to consider this function, and we're going to ask, is there a composite function there? And again, if you look at that, we'll see that this right here is our composite function. Now, honestly, the function is within a function, so we've got about 2 embedded functions inside one of them, but we're still going to work this the same way we have been. So we're going to say let u equal, and the outside function is 7 to a power, so we're going to let the inside function be 3 minus x to the second power. Take that derivative. We have 2 times the quantity, 3 minus x, and then if we take the derivative of the inside with respect to x, we're going to end up with du dx as negative 2, the quantity 3 minus x. The negative comes from the derivative here. Next up is like we have been, du would be negative 2, the quantity 3 minus x dx. And we take a look at this, and again, if you notice, you've got this 3 minus x right there, and our dx over here. So we can go back to this and see that we have 3 minus x dx. Again, what we can do is to write those beside each other. It makes maybe a little easier to see how they are connected. We have an extra factor of negative 2, so we will multiply by a negative 1/2. And then we have exactly the same thing here that we have up here. So we're ready for our substitution number 1. And this would be the integral of 7 to the u power times 1/2 du. Again, that makes it 1/2 the indefinite integral of 7 to the u du. Now, we haven't talked about what do you do when you have a function such as 7 to the u power. So I'm going to refer you to the basic integration rules that are on page 286 of your textbook. And in there you will see that to integrate this is going to be the same thing as the natural log of the base of our exponent in the integrand. Actually, I'm going to make that 1 divided by the natural log of that times 7 to the u power plus c. So we would have here 7 to the u power divided by 2 times the natural log of 7 plus c. And we now need to write this in terms of x. So f of x, again, this would be f of u. So f of x would be, let's see, did we drop our negative somewhere? I think we did. It should have been negative 1/2, negative 1/2, negative 1/2. This would make this negative, the fraction. So we have negative 7 to the u power, and again, u is 3 minus x, that quantity squared. And the exponent there, divided by 2 times the natural log of 7 plus c. I encourage you to check that problem, make sure that it is correct, that this function does generate this derivative up here.